FastAPI is a modern, high-performance web framework for building APIs with Python 3.7 and above based on standard Python type hints. So, what really makes FastAPI stand out in this ever-evolving landscape of web frameworks? Well, let's dig into the benefits and features that make FastAPI such an attractive option for developing those high-performance web APIs. First off, it's all about speed. FastAPI is built to be incredibly fast, like really fast. Thanks to its asynchronous capabilities, it allows us to handle many requests simultaneously, which can lead to a significant performance boost. But it's not just about speed. It's also about how easy it is to use. FastAPI leverages Python type hints, which means we can write cleaner, more robust code. This type hinting not only provides better auto-completion in your IDE, but also generates automatic interactive documentation for our APIs. Pretty neat, right? No need to write separate documentation. FastAPI does that for us. Think about how much time that saves. Now, another fabulous feature is FastAPI's support for data validation. It uses Pydantic under the hood, which ensures that the data types passed into your API endpoints are exactly as expected. Having this built-in validation means fewer bugs and more reliable applications. Oh, and did I mention it's also highly customizable? We can easily integrate it with databases, authentication schemes, and more, making it super versatile. So whether you're building a simple web application or a complex microservice architecture, FastAPI gives you the tools to do it efficiently and effectively. All this makes it a standout choice for developers looking to create high-performance web APIs. So let's get ready to explore FastAPI in action and see firsthand how it can transform the way we build web APIs. So far, we've learned that MongoDB offers a flexible NoSQL database solution that's just perfect for modern applications, allowing us to store unstructured and semi-structured data. We've also explored the farm stack, zooming in on how FastAPI, MongoDB, and React work together, especially when it comes to user management and those dynamic data structures that make our lives easier. Now, key features of MongoDB include its amazing scalability through horizontal sharding and those powerful querying capabilities that really simplify how we access data. As we move forward, we'll dive deeper into using FastAPI to craft efficient web APIs, unpacking its unique features and practical applications. It's going to be a lot of fun, so stay tuned. FastAPI's design focuses on performance, ease of use, and, of course, the developer experience. It's built on top of Starlet for the web components and Pydantic for handling data efficiently. Now, the first thing to note about FastAPI is its speed. Thanks to its asynchronous capabilities, FastAPI can handle thousands of requests per second, making it one of the fastest web frameworks out there. This is especially important for applications that face high traffic demands. So let's look at how we can harness this performance boost. A great way to do this is by creating a simple endpoint that echoes back whatever message you send it. You see, this not only demonstrates how responsive FastAPI is, but it also shows off just how easy it is to get started. So, if you're curious about boosting your web application's performance, FastAPI is definitely the way to go. The figure titled Key Advantages of FastAPI for High-Performance Web APIs presents a grouped bar chart that showcases 5 key advantages across the x-axis: speed, ease of use, data validation, asynchronous support, and community support. On the y-axis, we have an importance scale ranging from 1 to 10. Each bar is annotated with its corresponding numeric value. So, speed hits a solid 9, ease of use stands at 8, data validation also earns a 9, while asynchronous support nails the top score at 10, and community support follows closely at 8. The most striking observation here is that asynchronous support reaches that maximum importance value, a perfect 10, indicating this feature is viewed as the single most critical capability for high-performance APIs. Now, speed and data validation aren't far behind, both sitting at 9, underscoring that both raw throughput and reliable input-output handling are nearly as essential. On the other hand, ease of use and community support with scores of 8 reveal a strong, yet slightly lower focus on developer ergonomics and ecosystem backing. From these figures and their relative heights, we can conclude that FastAPI's strengths are heavily weighted toward asynchronous operation and robust data validation, while developer productivity and community resources remain key supporting factors. Overall, the bars cluster at the upper end of the scale, suggesting that multiple complementary attributes are considered critical when building high-performance web APIs. Now, let's take a look at how we can implement a simple endpoint using FastAPI that echoes back a message provided in the URL. In this code, we start by importing FastAPI and creating an instance of the application. The @app.get/echo/message decorator defines a GET request endpoint called echo, where message is a path parameter. This path parameter lets us capture a string message directly from the URL. When a request is made to this endpoint, the echo function is invoked asynchronously, which is crucial for performance as it allows handling multiple requests at the same time. Inside the function, we return a JSON response that contains the same message received in the URL. This really shows off FastAPI's powerful ability to create responsive web applications with minimal code. So, when the application is running and you make a GET request to, say, echo/hello, the server sends back a JSON response, message equals hello. This demonstrates the effective communication between the client and server and really showcases the benefits of FastAPI's non-blocking I/O capabilities. In this code, we've defined a simple endpoint that receives a message through the URL parameters. Now, notice the use of the async keyword. This allows our FastAPI application to handle requests asynchronously. So, when you run this application and make a GET request to /echo/hello, you'll receive a JSON response that echoes back the message. It's pretty neat, right? Now, one of the best features of FastAPI is its non-blocking I/O, which means the server can handle multiple requests at the same time while it waits for responses. This capability significantly improves throughput and overall performance, making your application much more efficient. So, remember, using async functions is a powerful way to enhance your web applications. Let's take a moment to discuss how straightforward it is to define data models with FastAPI using PyFastP. PyFastP really makes it easy by leveraging Python's type hints to declare data models. This not only cleans up your code, but, here's the best part, it provides automatic data validation. For instance, if you want to create a user model, you can do that effortlessly. Just, picture it. You define your model, and PyFastP validates the data for you before it even hits your database. So, let's dive into how you typically set this up. You start by importing Pydantic, defining your user class, and then you just specify the fields you need, like name and email. It's that simple. And, well, as your application grows and you add more complexity, having data validation baked right in saves you a ton of headaches down the line. Trust me, you'll appreciate this when it comes to debugging. So let's keep this in mind as we continue exploring FastAPI. It's not just about defining routes, it's about building a solid foundation with your data models. Now let's see how we can define a data model for user management using Pydantic. In our example, we're going to create a user model that specifies the structure of user data expected in API requests. This model includes three attributes: username and email, both of which are required fields, and full name, which is optional and defaults to none if not provided. This approach allows FastAPI to automatically validate incoming requests against the defined model, ensuring that only properly structured data is processed. If a request is made with missing or wrongly formatted data, FastAPI will return a clear error message. This not only enhances the user experience, but also reduces the amount of manual validation code you need to write. By leveraging Python's type hints, we achieve a cleaner code base and take advantage of automatic data validation. This not only streamlines the development process, but makes the API more robust and reliable, taking us a step closer to effective user management in our application. Next, we'll implement an endpoint that utilizes this user model to create new users effectively. In this example, we're going to define a user model with three attributes. Now, the username and email are required fields, while the full name is optional. What's cool about FastAPI is that it automatically validates incoming requests to ensure they conform to our model structure. So, if a user sends a request with missing or invalid data, FastAPI provides a clear error message, which is super helpful and means you don't have to write a ton of boilerplate code yourself. Now, let's dive into how to implement a post endpoint that creates users using this model. Just imagine, with a few lines of code, you'll have a working endpoint that not only validates, but also handles user data gracefully. All right, let's get started. Now, let's talk about implementing a post endpoint to create users using our previously defined user model. In this code sample, we're defining a new endpoint at the path /users with the @app.post decorator, which, by the way, specifies that this endpoint will handle post requests. The createUser function takes one parameter called user, and this is of type user. What that means is FastAPI will automatically validate the incoming JSON data against the structure of the user model. This ensures that both the username and email fields are present and valid, while it allows full name to be optional. Now, when a post request is made with a JSON body containing the user data, FastAPI processes that and hands off the validated data to our createUser function. The response from this function is a JSON object that includes the user data returned in exactly the same structure it was received. This enhances both clarity and maintainability. This smooth integration of data validation and structured responses minimizes the amount of manual handling and error checking that developers have to worry about. So it really helps you focus on building robust features while keeping expectations clear for how data is managed within your application. When you send a post request with a JSON body that holds the user's data, FastAPI kicks in and validates it against the user model. If everything checks out, it will return that user data in a structured format. Now, this is fantastic because it minimizes the amount of manual validation code that you need to write. This, in turn, enhances maintainability and readability of your code, making it easier to work with over time. It's a win-win situation. One of the coolest features of FastAPI is its automatic generation of interactive API documentation. By default, FastAPI creates this super user-friendly interface that allows you to test your API endpoints using Swagger UI and Redoc. What does this mean for you? Well, it means you can visualize and interact with your API right in your browser. And honestly, that significantly improves your development experience. Just imagine being able to see how everything works without jumping through a ton of hoops. It's pretty neat. So, every time you set up your API with FastAPI, you're not just building an endpoint, you're also getting that slick interface to play around with your API. Right? How awesome is that? Right? How awesome is that? All right. So let's dive into how you can access this feature. After you've got your FastAPI application up and running, head to your web browser. Now type in http://localhost 8000/docs to access the Swagger UI. Or if you prefer, you can go to http://localhost 8000/redoc for the redoc interface. Once you do that, you'll be greeted with a fully functional interface. It's pretty impressive, right? Here you can view all your available endpoints, submit test requests, and see the responses in real time. It's like having your own playground where you can experiment and see exactly how your API behaves. In fact, FastAPI utilizes Open API standards, which means you can effortlessly integrate your API with a variety of tools and services that support Open API specifications. This really fosters an ecosystem of integration. It allows developers to easily make APIs accessible for use by front-end applications or other services. Isn't that just fantastic? So, whether you're building a small app or something more complex, you'll find that integration with FastAPI helps streamline your development process. It's all about making your work more efficient and effective. So remember, embracing these standards can really open doors for your projects in ways you might not have imagined. As we proceed, let's consider error handling in FastAPI, which is designed to be intuitive and straightforward. You can define custom exception handlers to enhance the user experience, returning appropriate error messages when something goes wrong. This flexibility not only informs users of what happened, but also guides them on how to proceed. For example, when a user hits a snag, instead of just seeing a generic error message, they could receive something specific, like, "Oops, that resource could not be found." This small detail can really improve their interaction. Now, implementing these custom handlers is pretty simple. You just create a function that takes in the request and exception, then returns a response that fits your needs. So whether it's logging the error, sending an email notification, or just showing a friendly message, you have the tools to manage it all effectively. Keep in mind, a good user experience is all about clarity and ease. Embracing error handling in your FastAPI is a fantastic way to build trust with your users. Now, let's explore how we can implement error handling in our FastAPI application using custom exceptions. In this snippet, we're going to define a GET endpoint that retrieves an item based on its ID. The path parameter, item ID, is expected to be an integer. Now, here's the catch. If the provided item ID isn't 42, the application raises an HTTP exception. This triggers a 404 status code along with a clear message stating "Item not found." This method really showcases FastAPI's built-in error management capabilities, making it easy to give informative feedback to clients while keeping your code clean and organized. By defining custom HTTP responses, you significantly enhance the user experience when an error pops up, ensuring that clients truly understand what went wrong. This intuitive error handling mechanism is part of what makes FastAPI such an attractive choice for developers looking to build high-performance APIs with robust and user-friendly interfaces. When someone tries to access an item that doesn't exist, FastAPI raises an HTTP exception. This action sends back a 404 status code alongside a descriptive message. Now, why is this important? Well, it means you can manage errors effectively while providing clear feedback to clients consuming your API. The sensible design of FastAPI keeps your error management clean and straightforward, allowing you to maintain a healthy and responsive API experience. This approach isn't just functional, it's a key part of building robust applications. So remember, having clear error messages helps everyone understand what's going on, making your API so much easier to work with. let's not forget about authentication and security, which are paramount in any web application. FastAPI comes with built-in support for handling security features, making it easy to include OAuth 2 flows, API key-based authentication, or even JWT tokens. So you have a lot of options here. It helps ensure that only the right people can access your data, which is super important. Forgetting about security could lead to all sorts of issues, right? So let's embrace these features that FastAPI provides and make sure our applications are secure. Suppose you want to implement a simple API key authentication mechanism with FastAPI. Now, the implementation could look something like this. First, you would import the necessary modules, specifically FastAPI and a few other components for handling security. Then you'd set up your FastAPI app. After that, add a dependency that requires an API key. This could be done using a function that checks for the API key in the request header. If the key matches what's expected, great, you can proceed. If not, you return a 401 unauthorized status. It's pretty straightforward, right? And that's essentially it. You've got a simple yet effective API key authentication system in place. You can then expand upon that as needed for your project. So you see, setting this up doesn't have to be complicated at all. Now, let's implement a simple API key authentication mechanism using FastAPI. In this implementation, we'll define a custom security dependency by first importing the necessary modules like depends, HTTP exception, and API key header. The API key header class will help us read the API key from the request headers. Specifically, we're looking for it under the name XAPI key. Next up, we're going to create an asynchronous function called getAPIKey that takes that extracted API key as input. Inside this function, we'll check if the provided API key matches what we're expecting. Let's say it's expected API key. Now, if that verification fails, we'll raise an HTTP exception, which gives us a 403 forbidden response along with a clear and informative error message, making sure that unauthorized users cannot access our secure data. After that, we'll define the API endpoint, which will require a valid API key in the request. By using the depends function, we ensure that the getAPI function is called to validate the API key before we grant access to that protected data. If everything checks out, the API will respond with a JSON object containing that protected data. This seamless integration of security into our FastAPI application really helps in protecting sensitive information while keeping our code clean and organized. Here, we've defined a custom security dependency using FastAPI's security utilities. Now, when a request is made to secure data, it checks for the presence of a valid API key in the header. If the API key isn't correct, the user receives a 403 forbidden error, which is just a way of saying, "Oops, you can't access this." This elegant integration of security makes it so much easier to build secure applications, allowing developers to focus on creating great features, not worrying about vulnerabilities. So, let's appreciate how these built-in tools streamline our development process and keep our data safe. Let's dive a little deeper into asynchronous features, which are super important for achieving efficient performance, especially when we're working with Python. So FastAPI really leans on Python's async and await syntax, allowing developers to write asynchronous code in a way that feels natural. This is particularly advantageous when we're dealing with tasks that might be blocking, such as running database operations or consuming external APIs. It's all about keeping our applications responsive and efficient. So, let's keep exploring how we can harness these tools in our projects. Imagine you're tasked with fetching data from two different external web services, and you need to aggregate that into your API response. Now, here's where asynchronous programming comes in handy. It's a game changer. By leveraging this concept, you can initiate both requests at the same time, allowing your application to work more efficiently. So instead of waiting for one response before starting the other, you're essentially multitasking. This means you can handle more requests without blocking your main thread. Pretty neat, right? As we dive deeper, you'll see just how powerful this can be for optimizing performance in your applications. Now, let's take a look at how to asynchronously fetch data from multiple external services and aggregate that data into a single API response. We begin by defining two asynchronous functions, fetch data from service A and fetch data from service B. These functions utilize the HTTPX library to perform non-blocking HTTP GET requests to their respective service endpoints. By using async with httpx.async client, we ensure that our requests are handled efficiently, allowing other tasks to run concurrently while we wait for the responses. Now, next up, we create an API endpoint called getAggregatedData. This is where the magic happens. We execute both fetching functions simultaneously by employing asynco.gather. This nifty function allows us to launch both tasks at once, significantly reducing waiting time and boosting the overall responsiveness of our API. Once we receive both responses, we'll return them in a structured format that encapsulates the results from both services. This approach exemplifies FastAPI's asynchronous capabilities, enabling developers to build high-performance applications that can handle multiple requests quickly and efficiently, making it perfect for modern web development scenarios. In this example, we're going to dive into HTTPX, which is an asynchronous HTTP client, and it's pretty cool because it allows us to fetch data from two different services. And we can do this concurrently. Now, what's really neat here is that we're using the asynchro.gather function. This function enables us to run both fetching operations at the same time, which means we're significantly shortening the total response time for clients of your API. It works by leveraging the event loop efficiently, ensuring that FastAPI can handle a multitude of requests without any delay. So when you set this up correctly, you'll notice a smoother experience, both for you as a developer and for your users. Imagine handling multiple requests seamlessly. Pretty nifty, right? With this method, you're really maximizing the capability of your application, making it robust and responsive. So, let's get our hands dirty and start implementing some code with HTTPX and asynchrono. Let's also dive into dependency injection, which is a super powerful feature of FastAPI that really enables you to create modular and testable code. So, what are dependencies? Well, they can be anything from your database connections to configuration settings, and the beauty of it is that they can be automatically injected into your path operations or even other dependencies. This makes your code cleaner and more maintainable. Imagine not having to hard code connections every time you need them. That's a game changer, right? So, as we explore this feature, keep in mind that dependency injection helps you manage your application in a more structured way. It simplifies testing too, allowing you to mock dependencies without much hassle. Isn't that cool? All right, let's get into how to implement this in your FastAPI projects. For instance, if you want to connect to a MongoDB database, you can set up a dependency that provides the database connection, making it accessible to any endpoint that needs it. This means whether you're fetching data or storing it, every part of your application can easily tap into that connection without reinventing the wheel every time. Just think about it. You're simplifying your code, keeping it clean, and ensuring that everything has access to that crucial database resource. So when configuring your application, this approach not only boosts efficiency, but also enhances maintainability. So remember, every endpoint can benefit from that shared connection, fostering a more interconnected and robust application architecture. Next, we'll write some code to connect our FastAPI application with a MongoDB database. First, we need to import the Mongo client from the PyMongo library, along with the depends function from FastAPI. After that, we'll create an instance of Mongo client. This will establish a connection to our MongoDB server, which is running locally on the default port. Pretty straightforward, right? Now, to define the database we'll use, we access it through our client instance and assign it to the variable DB. Next, to make this database accessible to our endpoints, we'll create a function called getDB. This function will simply return our DB object. Now, let's look at the read users endpoint. With FastAPI's handy dependency injection, this endpoint will utilize our getDB function to interact with the database. So, when a GET request is sent to /users, it will fetch all user documents from the users collection and return them as a list. This structure not only promotes code reusability, but also keeps our application modular, allowing for easy adjustments and scalability for future updates. In this case, the getDB function acts as a dependency that exposes the database connection to the read users endpoint. Now, the beauty of this setup lies in its simplicity and reusability. You only need to define the database connection once, and you can use it across multiple endpoints while keeping your code clean and organized. It's like having a central hub for your database access, making everything feel streamlined, right? So, whenever your read users function needs to interact with the database, it just taps into this single connection. And that means you can manage your connections more easily, avoid redundancy, and, let's be honest, keep your code looking sharp. So, whether you're reading data or making changes, having that neat, reusable connection in place is a game changer. This way, you're setting yourself up for success with cleaner, more maintainable code. And isn't that what we all strive for? As we look ahead, it's essential to consider the community and ecosystem surrounding FastAPI. You see, the rapid adoption of FastAPI has really sparked a vibrant community that's contributing tons of resources, projects, and tools. I mean, from middleware libraries to authentication frameworks, the variety is just expanding. This growing ecosystem is all about making your development process easier and more efficient. So, if you're diving into FastAPI, keep an eye on these resources. They can be incredibly helpful as you build your applications.
Moreover, the framework's creators are actively engaging with the community on GitHub, taking the time to address issues, evolve the software, and really listen to user feedback. So, as a developer, you have the opportunity to contribute too. You can report bugs, suggest cool new features, or even lend a hand by writing documentation. This sense of community is vital. It ensures that FastAPI will keep growing and adapting to meet the ever-evolving needs of developers, which is pretty fantastic, right?
In conclusion, FastAPI really shines as a high-performance, user-friendly web framework specifically designed for building APIs. With its focus on speed, type safety, automatic documentation, and robust asynchronous capabilities, it's perfectly suited for the demands of modern web development. As you embark on creating your applications, remember to leverage FastAPI's powerful features to craft efficient APIs that are not only easy to maintain, but also scalable. It's like having the best toolkit in your developer's toolbox.
Now that we've covered the essential aspects of FastAPI, I really encourage you to put this knowledge into action. So why not start building your own APIs with FastAPI? Dive into its extensive documentation. There's so much to explore. Experiment with its features and see what you can create. The journey into high-performance API development is exciting, and FastAPI is a fantastic companion for that adventure. So happy coding, and remember, the possibilities are endless. You've got this.